welcome to the Joy of Architecture. Today we're diving deep into one of the most intriguing puzzles in the tech world. It's that often confusing, always evolving landscape of senior technical roles in software. So if you've ever wondered who does what when you hear software architect or maybe principal engineer, you're definitely in the right place. Our mission today is really to cut through some of that ambiguity and map out these distinct yet, well, often overlapping responsibilities.
That's right, and we'll be drawing insights from a pretty comprehensive research study to give you a clearer picture. Think of it as a guide, understanding where that strategic vision meets the hands-on code and maybe where your own expertise fits in.
Okay, let's unpack this then, because when we hear architect in software, it can mean so many things, can't it? Let's start by maybe defining some of the key architecture roles, perhaps starting from the highest strategic level and working our way down.
Absolutely, yeah. Good place to start. So right at the top, operating at the highest strategic level, we find the enterprise architect, the EA. Their focus is really that holistic alignment of business goals, technology strategy, data, everything across the entire organization.
Wow. Okay, so they're not just thinking about one system, but the whole digital city, so to speak, like the urban planners.
Precisely. Yeah, that's a great analogy. Their core job is that strategic vision and road mapping, identifying priorities for change, defining the overall enterprise architecture vision, and crucially, translating business strategy into, well, actual technical delivery plans. They also establish the broad architectural principles and policies, kind of the rules of the road for everyone, ensuring consistency and, long-term resilience.
So very high level, almost entirely strategic.
Almost entirely, yeah. Defining the what and why at that foundational level. So you'd see minimal, if any, hands-on coding from an EO. Their outputs are things like vision documents, strategic roadmaps, those high-level principles we talked about.
Fascinating. Okay, so if the enterprise architect sets the city plan, who designs a specific building within that plan?
Good question. That brings us to the solution architect, or SA. They're the ones designing solutions for specific problems within the organization, usually working directly with delivery teams. They essentially bridge that high-level enterprise strategy with the concrete technical implementation for a particular solution or maybe a business domain.
Okay, so they're making sure the solution actually solves the right problem, not just any problem.
Exactly. Problem definition and scope are paramount for them. They create the technical blueprints, the detailed component specs for that solution. They're constantly evaluating and selecting technologies, staying current, looking at deployment options, and they're vital communicators too. Translating complex tech stuff for, non-technical stakeholders are that critical link.
Right, and coding. How hands-on are they?
Well, they aren't primarily coders, but most LSIs we see have a solid maybe 5-10 years of hands-on experience behind them. They might develop a proof of concept, a POC, or review code sometimes, but it's generally for validation or setting an example, not, daily production coding. They're deliverables. Detailed technical designs, solution recommendations, maybe test plans.
Okay, that makes sense. Now let's get even closer to the actual construction site. Who's responsible for the design and build of the specific technical architecture? The real nuts and bolts.
Right, that's the technical architect, often just called a software architect. This role is usually embedded within or maybe across multidisciplinary teams, and they're considerably more hands-on than either the EA or the SA. They're the ones really designing the system's inner workings.
So these are the folks creating the actual detailed blueprints, defining how system components interact, data flow, all that.
That's spot on, yeah. Technical design and implementation, that's their core. They do structured analysis of technical issues, translate that into detailed architectural blueprints, define specific system components, data flows, integration points, the whole shebang. They also play a big role in technology selection, setting coding guidelines, and providing technical leadership and mentorship within their teams. Oh, and quality assurance, performance optimization too.
And they definitely code.
Oh, yeah, they absolutely get their hands dirty. Technical architects usually come from a development background. They're comfortable with the tools, the code. They might write and test code for non-critical paths, do architectural spikes, those small experiments to test an approach or build prototypes. Yeah. And they definitely do code reviews. Their deliverables include detailed diagrams, tech specs, prototypes, and often, production quality code.
Okay, so that covers the main architect titles. But the world of senior technical roles isn't just about architects, is it? There's this really strong parallel path for engineers who want to stay deeply technical but maybe not go into people management. Let's explore those high-level individual contributor roles.
A really important path.
Who sits at the most senior end of that spectrum?
Yeah.
The one influencing maybe a whole department.
That would typically be the principal engineer, or PE. A principal engineer is a senior technical expert who leads and influences the development and implementation of an organization's tech strategy. They often bridge that gap between executive management and the technical staff. They're recognized experts across multiple tech domains within their subdepartment or department, basically senior technical leadership without the direct reports.
So driving strategy, making critical technical calls, but still on that IC track, that's a pretty unique blend, isn't it?
It really is. Their core responsibilities include strategic technical leadership, driving the direction for their part of the org, often with like a 6-month, maybe even longer view. They're heavily involved in high-level design and architecture, proposing initial implementations, leading architectural decisions across teams. They're also the ones tackling the problems with the highest scope, complexity, ambiguity. Our research showed PEs often act as this critical veto board for architectural decisions, which is fascinating.
Wow, a veto board. That's significant influence.
Right.
So given that, how hands-on are they with actual coding day to day?
Well, they are definitely technical ninjas, as some say, but their coding is typically minimal. It's usually focused on highly complex or mission-critical pieces, maybe prototyping something foundational. Their impact comes more from driving technical excellence, mentoring other experts, influencing those big cross-team or company-wide initiatives. You'd see them producing technical proposals, strategic roadmaps, architectural designs, solutions to those really thorny, high-scope problems.
Okay. And a step down from principal? Maybe, but still incredibly influential. We have the staff engineer. What's their main focus?
Right. The staff engineer, or SE. This is a professional engineer with advanced technical and leadership skills. They typically work across teams, maybe delivering features, doing major refactors, or updating systems. They hold a leadership role on the technical side, again, usually without direct reports.
So they're coordinating across teams, solving problems, but still very much involved in the code.
Precisely, yeah. Their responsibilities include technical leadership, mentoring junior engineers, fostering a good work culture. They actively coordinate efforts across teams to hit business goals, define and execute plans for features or system maintenance, manage those larger refactors. They also champion process improvement, fight technical debt. They're great at understanding systems, documenting things clearly, and importantly, they influence without direct authority, using their tech expertise to build consensus.
And coding. Still a big part of the job.
Yes, absolutely. Staff engineers are still doing significant coding and individual contributor work. They might pick up slack to fill in gaps, as one source put it, or contribute directly to the code base, especially for complex or foundational parts. Their deliverables often include execution plans, internal docs, completed refactors, tech guidance, and yes, definitely software code.
Okay. And finally, at the very pinnacle of this individual contributor track, we have the distinguished engineer. That title just sounds like the ultimate tech authority.
It certainly does, yeah. The Distinguished Engineer, or DE, really represents the peak of technical achievement and influence in many organizations. This is often an executive tier IC, parallel to maybe a director or even VP level. They are established, often industry-recognized experts.
Wow. So they're shaping the future direction of the whole company, maybe even influencing the industry.
That's the scale of their long-term strategic impact, yes. They focus on advising senior management, shaping the company's overall technical direction and standards. They identify those critical, often ambiguous problems that need solving to set the stage for future innovation. Their influence spans multiple teams or the entire organization. They act as force multipliers, elevating the technical capabilities all around them. They're often thought leaders, too, representing the company externally at conferences through publications.
So with that kind of broad strategic view, coding must be pretty infrequent for them.
It becomes less frequent, yes. But their ability to architect, design, and troubleshoot the most complex systems remains absolutely crucial. Their deep technical expertise is the foundation of their influence. Their impact comes through that expertise, strategic insight, and mentorship, rather than daily production coding. They might contribute to foundational projects or maybe high-impact prototypes, but they're not writing day-to-day code. Their deliverables are things like strategic technical roadmaps, long-term architectural visions, maybe frameworks, and solutions to the company's absolute hardest technical challenges.
Okay, so we've outlined these distinct paths, the architects and the senior ICs. Now, the real deep dive begins when we ask, Where do these seemingly separate worlds actually collide or, diverge? This is where it gets really interesting, I think, for anyone navigating their career.
Totally agree. And if we connect this to the bigger picture, it's about understanding those core distinctions, but also the surprising overlaps. We can look at this across several dimensions, right? Like scope, it ranges dramatically. You've got the entire organization for an EA or a DE, then maybe down to a single solution for an SA, or specific technical designs for a TA or maybe a staff engineer. Principal engineers usually operate across multiple teams or a whole subdepartment. So scope varies a lot.
Right. It's not just how wide their impact is, but also the level of abstraction they operate at. What about strategic versus tactical involvement? How does that differ?
That's another key differentiator. EAs and DEs are highly strategic, thinking long-term vision. Principal engineers, too, highly strategic, often looking 6 months to multiple years out. Then you have SAs, TAs, and staff engineers who are more of a blend. They balance strategic design with more tactical implementation, guidance, execution. And then there's the hands-on coding piece, minimal to none for EAs and DEs, occasional for SAs, maybe for POPAs, more moderate for TAs and staff engineers, prototypes, critical path code, refactors. Principal engineers, again, minimal coding, but focused on that highly complex or mission-critical stuff.
So what does this all mean for the fluidity between these roles? You mentioned overlaps earlier. How significant are they?
What's really fascinating is just how fluid these distinctions can be in practice. Our research showed that a senior developer or a tech lead might often perform architect duties without the formal title, which means architectural work isn't just confined to one job title. It's a set of responsibilities that can be picked up by various senior folks. And there's significant overlap, especially between principal engineers and architects. In some companies, the titles are almost interchangeable. PEs are increasingly involved in high-level design, proposing solutions for scaling, performance things traditionally seen as architect territory. They often become the de facto architects for their domains.
So the lines aren't nearly as clear-cut as the titles might suggest, which makes sense, given how deeply technical these principal engineers are.
Exactly. The primary distinction often boils down to the depth versus breadth of technical involvement and the level of abstraction. TAs and staff engineers are typically closer to the code, focused on implementation details. SAS operates slightly higher, bridging strategy and execution. EAs are at the highest strategic tier, minimal direct implementation involved. And the senior IC track principal, staff, distinguish a really robust alternative to management. It lets technical experts drive significant architectural and strategic impact. In fact, in many modern tech companies, the standalone software architect title, especially if it's not deeply embedded or hands-on, might even be diminishing in distinct value because PEs often fulfill very similar functions, owning solutions end-to-end.
Right. And it's not just the title. The company you work for must dramatically shape these roles too, right?
Mhm.
What stands out to you about how these roles shift across different kinds of organizations?
Oh, hugely important point. Context is everything. Take tech product companies, think Google, Amazon, places like that. Our research shows they have highly formalized IC ladders, principal, senior principal, distinguished engineers running parallel to management tracks. It's very structured. The emphasis there is squarely on deep technical expertise and broad impact. Principal engineers are often these visionaries and hands-on builders tackling the hardest problems. And distinguished engineers, they're sometimes expected to literally change the industry, set new directions. It's a very clear path for tech experts to lead without managing people.
Okay, a strong technical path. What about the other end of the spectrum, say, large traditional enterprises, banks, insurance companies?
In large enterprises, you often see a more formal hierarchical separation between architect and engineer roles. This is often driven by complex legacy systems, really stringent regulatory requirements, and a very strong focus on risk management. Enterprise architects are absolutely critical here for long-term business resilience, aligning IT with strategy and navigating that complex web of compliance, local, state, federal. You'll also find more specialized architects common, like business architects, data architects, security architects, each playing a really vital role.
Makes sense given the environment. And how do consulting and services firms fit in? Their work seems so client-driven.
Yeah, consulting and services firms are very client-centric. Architects and principal engineers there provide expert advice on design, construction, compliance for all sorts of clients. They get involved across the whole project lifecycle, from the initial chat to making sure code complies, advising on sustainable design, you name it. These firms look for people with really broad technical skills, strong dev backgrounds, fluent in multiple languages, knowing various architectural patterns like microservices or cloud native, across different cloud platforms. They often act as hands-on advisors or even interim technical leaders for clients. Their deliverables might range from design consults to managing technical debt or designing complex CRM systems. They have to be incredibly versatile.
Wow, sounds like they need to know a bit of everything. Finally, what about startups and scale-ups? I imagine roles get pretty blurry there.
You're spot on. In startups and scale-ups, there's a huge blurring of roles, lots of wearing many hats. A senior dev or tech lead often does architect work without the title. Our study found one startup where the software architect actually spent like 60% of their time coding foundational services early on. A software architect in a startup often does almost everything: planning, coding, coordinating. Staff engineers, too, they wear many hats because things change so fast. But even with the speed, architects are crucial for orchestrating development and building robust, scalable foundations early on, trying to avoid massive technical debt later. The trade-off: startups offer a substantially higher level of influence and impact, rapid learning, direct influence on product, less bureaucracy, but, less clear career ladders, more instability, maybe lower initial pay. Distinguished engineer roles are also pretty rare there. It often tops out at principal. And what's really fascinating here is how these roles aren't static at all. They're constantly evolving, right? Driven by new methodologies, new technologies.
Tell us more about that evolution. I keep hearing about the ivory tower architect being a thing of the past. Is that true?
Largely, yes. That's a key trend. The shift away from traditional detached architecture towards more embedded or decentralized models. The ivory tower architect, someone completely removed from implementation, risks becoming disconnected from business needs. Their designs might be great on paper, but unfunded or undeliverable. And the value of documentation drops if the people writing it are far removed from the people using it. So this has led to a rise in embedded, hands-on roles. Technical architects are now commonly found right within multidisciplinary teams. Even a tech lead can effectively fulfill the architect role. Principal engineers often operate embedded or across teams, aligning things and magnifying value. It's really about architectural concerns becoming a shared responsibility across various senior technical roles, not locked into one architect title.
So it's less about a specific job title and more about the architectural work being distributed and handled collaboratively.
Precisely. And that leads directly to the next big trend: role convergence between architects and senior ICs. Companies are getting much better at formalizing these IC pipelines principle, staff placing them at the same seniority level as managers or directors. It's a critical strategy to keep top technical talent. Amazon's principal engineers, for example, being technical peers to high-level managers, even acting as that veto board. That's a powerful statement. This convergence also means that in many modern tech companies, that standalone software architect role, especially if it's not hands-on or embedded, might be losing some of its distinct value because PEs are often doing very similar things, earning solutions end-to-end.
Right. And what role do things like agile, DevOps, and now platform engineering play in driving these changes? They seem central to this evolution.
Oh, profoundly influential. Agile methods encourage iteration, faster feedback. That requires architects to design systems that are adaptable, ready for frequent changes, moving away from rigid, big upfront designs. DevOps blurs the lines between dev and ops, fosters collaboration, automation, continuous delivery. It means architectural decisions become a shared responsibility involving all stakeholders. Things like infrastructure as code or IAC directly align architecture with operations, leading to faster, more consistent deployments.
And platform engineering feels like the next level of that, doesn't it? Focused on the developers themselves.
Exactly. Platform engineering is often seen as the next step in DevOps. It's all about developer enablement by basically productizing the infrastructure and operational tooling. Platform teams build reusable components, automate infrastructure, think GitOps workflows, self-service provisioning, CI/CD templates. This shifts the architectural focus towards designing effective internal developer platforms, or IDPs. Suddenly, developer experience, or DevX, becomes a critical architectural concern. How easy is it for our developers to build, test, deploy? Architectural decisions get codified, version controlled, leading to more consistency and faster feedback.
Okay, so if these roles are constantly changing, constantly evolving, what does the future hold? And maybe more importantly for our listeners, how do you actually grow into these influential positions?
It really raises an important question. What's next? The future seems to demand what you might call a polymath architect or engineer. Future leaders will need deep understanding across multiple domains: security, data, infrastructure, and especially AI, to handle these increasingly complex, cloud-native, AI-driven distributed systems. In-depth knowledge of cloud platforms, AWS, Azure, Google Cloud, strong DevOps integration, and always prioritizing security and compliance. These are becoming table
And
stakes.
AI, that's going to be huge, right? Not just as a feature we add, but fundamentally changing how we build software itself.
Right.
Absolutely. AI isn't just another feature set. It's poised to reshape how software is designed, built, and operated. Architects and senior engineers will need to design for AI systems that leverage it effectively and also design with AI using AI-assisted development, automated operations. Projections suggest AI incorporation could exceed 50% in development, leading to vastly automated platform operations. And alongside that, there's the growing primacy of developer experience and thinking of internal tools as products, internal product thinking. Treating your internal developers like customers is key to attracting and retaining talent. Platform engineering really doubles down on this.
So for professionals listening who aspire to these roles, what are your key recommendations? How do they get there?
Okay, three main things come to mind. First, cultivate a hybrid skill set. It's not just about technical brilliance anymore. You need strong communication, influence, business acumen, adaptability. This means building a strong educational base, getting extensive practical experience. Our research points to 5–10 years often being needed for these roles, maybe pursuing advanced certifications like CSDP or cloud-specific ones. Second, embrace the force multiplier mindset. Career growth at this level isn't just about your individual output, it's about elevating entire teams, the whole organization. That means proactively spotting systemic issues, championing best practices, enabling others through formal or informal leadership and mentoring. And finally, strategic career navigation and personal brand building are crucial. Progression isn't always linear. You need to make strategic choices, company type, specialization, proactively engage, lead initiatives, build a personal brand through thought leadership, community contributions networking, open source, conferences, writing, and always develop that keen understanding of business objectives to align your tech strategies effectively.
Wow. What an incredible deep dive into this really dynamic world of software architecture and high-level engineering roles. From those enterprise visionaries all the way down to the hands-on problem solvers, we've really explored how these roles define the tech landscape of today and tomorrow.
It really does raise an important question, though. As AI continues its rapid evolution, what new, maybe even more specialized or hybrid roles might emerge that completely transform the lines we've discussed today? Something to think about.
A truly thought-provoking question to leave us with. Thank you so much for joining us on this deep dive into the fascinating world of software architecture. If you found this insightful, please make sure to subscribe to Joy of Architecture for more in-depth explorations like this one.